Hello guys, today I'll be going with the 2025 AMC10B Problem 21. So each of the 9 squares in a 3x3 grid is to be colored red, blue, or yellow, such a way that each red square shares an edge with at least one blue square, each blue square shares an edge with at least one yellow square, and each yellow square shares an edge with at least one red square. Colorings that can be obtained from one another by rotations and or reflections are considered the same. How many different colorings are possible? So let's draw our graph. And there's 3 ways to choose what the center square is. So let's, without loss general, let's let that be R. So now let's set this be B, and this is one way to do that because setting B any other of these 4 spots can be achieved through rotation. So now then this must be yellow, this must be red, this must be blue, and this must be yellow. Alright, so now we are looking into these last 3 squares. So there are a couple ways. Let's say BYR. BYR is good. BYB, BRR, and BRY. So these are the 4 ways that we can put in the lower column, lower row, that are distinct of each other through rotation and reflection. So there are 4 ways to do this, and since there are 3 ways to arrange the center square, this is 12 ways in total. So C. AMC10B Problem 22. So a 7-digit positive integer is shown at random. What is the probability that the number is divisible by 11, given that the sum of the digits is 61? So a 7-digit number that adds 61. This is a very particular situation because 9 times 7 is 63. So there are only 2 possible numbers that can add to 61. We could have 9 sevens and 6 nines and 1 7, or we can have 5 nines and 2 8s. So in total, this is 7 choose 1, this is 7 choose 2, for a total of 28 as the denominator ways. That numbers that have sum of digits 61. So now we need to see how many of these are divisible by 11. So let's take a look at this case. Well, this case is divisible by 11 if we set 7 as one of the 3 inside values, as the divisibility rule of 11 is odd minus even. So we have 9. We have this, and as we can see, this sums to 11, and since it sums to 11, it's divisible by 11. So there are 1, 2, 3 choices where we can put the 7, as it has to be in one of the spots where it's minus. So this gives us 3 ways. Now, for the 8s, we have to put them in 2 minus spots as well, as this is also equal to 11. So there's 3 choose 2, which is 3. So our total sum is 3 plus 3 over 28, which is 6 over 28, which is 3 over 14. So our choice is A. AMC10B Problem 23. So a rectangular grid of squares has 141 rows and 91 columns. Each square has room for 2 numbers. Horace and Vera each fill the grid by putting in the numbers from 1 through 141 times 91 into 12,831 into the squares. Horace fills the grid horizontally. He puts 1 through 91 in order from left to right in row 1, puts 93 through 182 in row 2 for order from left to right, and continues similarly through row 141. Vera fills the grid vertically. She puts 1 through 141 in order from top to bottom in column 1, then 142 through 282 in column 2 in order from top to bottom, and continues similarly through column 91. How many squares get 2 copies of the same number? So we know, let's say the coordinates of the square are x and y, x comma y. Now Horace fills the grid 1 through 91 in order. So this is 91 times y plus x. And Vera fills it 141x plus y. We want to set these equal to each other. So this is 140x is equal to 90y. This gives us 14x is equal to 9y. So we can set this as x is equal to 9 comma 14, 18 comma 28, and all multiples of 9 and 14 work, all the way until 90 comma 140. But not to mention, we also have 1 1 also works, which corresponds to 0 0 in this case. And 1 1 obviously the first square gets counted 1 for both ways. So our total sum is 10 and 1, which is 11. So 5 AMC10B Problem 24. So a frog hops along the number line according to the following rules. It starts at 0. If it is at 0, then it moves to 1 with probability 1/2 and disappears with probability 1/2. For n is equal to 1, 2, 3, if it is at n, then it moves to n plus 1 with probability 1/4. 10 minus 1 with probability 1/4 and disappears with probability 1/2. What's the probability that the frog reaches 4? Let's use expected value. Expected value of 0 is going to equal 1/2 of the expected value of 1, as since there's also 1/2 expected value, but it disappears, so that would be 0. So now E1, there's 1/4 chance it moves to E2, and 1/4 chance it moves to E0, and if it disappears, it'll never be able to reach 4, so the probability of that is 0. E2 is equal to 1/4 E3 plus 1/4 E1. E3 is equal to 1/4 E2 and 1/4 E4. But what E4 is equal to 1, as E1 wins already, so 1/4. So now let's find the sum of this. So let's plug E3 into this equation. Then we get E2 is equal to 1/16 E2 plus 1/16 plus 1/4 E1. Let's multiply by 16. This gives us 15 E2 equals 1 plus 4 E1. Now let's take a look at this equation. This equation is just E1 is equal to 1/4 E2 plus 1/8 E1. So this just gives us 7/8 E1 is equal to 1/4 E2. Multiplying it on both sides, we get 7 E1 is equal to 2 E2. So let's multiply this equation by 7. Then we get 105 E2 is equal to 7 plus 28 E1. Let's multiply this equation by 4. 28 E1 equals 8 E2. So plugging this in, we get that 105 minus 8, which is 97 E2, is equal to 7. Or E2 is equal to 7 over 97. If E2 is equal to 7 over 97, then E1 is equal to 2 over 97, and E0 is equal to 1 over 97. And so our answer is E. By AMC10B Problem 25, so square ABCD has side lengths of 4, points P and Q line AD and CD respectively, with AP equal to 8/5 and DQ is equal to 10/3. Give me a second. A path begins along the segment from P to Q and continues by reflecting against the sides of A, B, C, D. If the path hits the vertex of the square, it terminates there, otherwise it continues forever. And with the vertex of the path terminate. Alright, so basically we can do a strategy that's called like just reflecting over. And so instead of putting it that, we can reflect it over and turning it into the next square. So it'll do something like this until it hits the vertex. Alright, so now we first of all, to do this method, we need to figure out the slope of the line. So let's turn this into coordinates. So the slope of the line is going to equal rise over run. So let's let this be the origin. Then this is equal to 10 over 3, comma 4. This is equal to 0, comma 8 over 5. So the slope is equal to 12 over 5 over 10 over 3. So this is just equal to 18 over 25. So the equation of our line is y is equal to 18 over 25x plus 8 over 5. Now we want to find the first intersection of this point with one of the square lines, and the square lines are always going to be in the form x. They're always going to be in the form x is equal to 4k, y is equal to 4k as well. So they all have to be divisible by 4. So let's plug in x equal to 4k in here. So then we get y is equal to 72k plus 40 all over 25. Since this has to be divisible by 4, we have that 18k plus 10 all over 25. 18k plus 10 is equal to 0 mod 25. Okay, so now from this we get that k is equal to 5 mod 25. Now if k is equal to 5 mod 25, then x is equal to 20. And then plugging in 20, we get 72. We get y is equal to 16. So now we want to see which vertice the line intersects at x x equals 20, y equals 16. So let's take a look. So we have 5 squares going on the x and 4 squares going on top. And this is the point where it'll hit. So we have A, B, C, D. This must be A, this must be D. And then this is what we have here. So now we have this is A, this is B, this is C, this is D, this is B, this is A. And so it should hit at point B. So thank you guys for watching. If you enjoyed this video, make sure to like and subscribe, and peace.